Welcome back friends in my YouTube channel TechTide Digital Lifestyle for our Induction Motor Complete course. Before starting this video, like and subscribe the channel. Today, we are going to study the testing of induction motors and how we calculate their performance from experimental data. Testing is very important because it helps us determine efficiency, various losses, and circuit parameters without loading the motor fully in a workshop environment. These topics are extremely important from ETO and COC examination points of view. First, let us understand why testing is required. By performing standard tests, we can separate different types of losses such as stator copper loss, rotor copper loss, core loss, and mechanical losses like friction and windage. Testing also helps us find equivalent circuit parameters, which are later used to predict motor performance under any operating condition. The most common test is the no-load or open circuit test. In this test, the motor is allowed to run freely without any mechanical load on the shaft. Rated voltage and frequency are applied to the stator, and we measure input voltage, current, and power using suitable instruments. Since the motor is running at nearly synchronous speed, rotor copper losses are very small, so the measured input power mainly represents core losses in the iron and mechanical losses such as friction and windage. Another important test is the blocked rotor or short circuit test. In this test, the rotor is physically locked so that it cannot rotate, and a reduced voltage is applied to the stator until rated current flows. Voltage, current, and power are measured again. Because the rotor is not rotating, slip is equal to 1, and core losses are small due to low voltage. Therefore, the measured power mostly represents stator and rotor copper losses. This test also allows us to calculate equivalent impedance, resistance, and leakage reactance of the motor. From these two tests, we can determine the parameters of the induction motor equivalent circuit. Using stator resistance measured by DC test and blocked rotor test results, we can calculate rotor resistance referred to stator, leakage reactances, magnetizing reactance, and core loss resistance. These parameters are then used for performance prediction. Efficiency calculation is another key outcome. Efficiency is defined as output power divided by input power. Input power is measured electrically, while output power is found by subtracting total losses from input. Total losses include stator copper loss, rotor copper loss, core loss obtained from no-load test, and mechanical losses. This is a very common numerical problem in exams. The circle diagram method is a classical graphical technique used to predict induction motor performance. Using no-load and blocked rotor test data, a circle is drawn on a current locus diagram. From this circle, we can determine current, power factor, torque, efficiency, and slip at any load condition. Although software tools are now common, this method is still taught for understanding and examination purposes. While performing tests, safety is extremely important. The rotor must be properly locked during blocked rotor test to avoid sudden rotation. Voltage should be increased gradually, correct rated instruments should be used, cooling should be allowed between tests to avoid overheating, and protective guards must be in place. These precautions are often asked as short questions. From ETO and COC exam perspective, make sure you can explain both tests with neat diagrams, describe how losses are separated, calculate efficiency from given data, and draw the approximate equivalent circuit. These topics form the backbone of performance testing questions. To summarize today's lecture, we studied why testing of induction motors is required, detailed procedures of no-load and blocked rotor tests, how equivalent circuit parameters are obtained, efficiency calculation, the circle diagram method, safety precautions, and exam-focused points. In the next lecture, Day 9, we will cover losses, efficiency and heating of induction motor, so keep following the playlist and continue learning. Thank you for watching this video. Please like and subscribe this channel and comment on video.